Yeah, good evening, children. I think we saw this question in the last class, right? We worked, I think, the answers to there are 8 subdivisions here. 1 second. Yeah. This question number 3 has 8 subdivisions. I think we tried the first 4 in the last class, right? Okay. I'll just tell you again. So what are we given in this question? We're given a quadratic polynomial, f of t. The variable involved is t. We have a quadratic polynomial. Now, what are the zeros of a quadratic polynomial? Alpha and beta. In general, we call alpha and beta as the 2 zeros of a quadratic polynomial. Now, what is the relationship between which are the coefficients of the quadratic polynomial? Which are the coefficients of the quadratic polynomial? A, B, and C. A, B, and C. A, B, and C are called the coefficients. Okay, because what is the standard form of a quadratic polynomial? Ax squared plus bx plus c. This is the standard form. So A, B, and C are called the coefficients. Okay, x squared is the coefficient of A. A is the coefficient of x squared, B is the coefficient of x, and C is the coefficient of x to the power 0. See, you can write this equation as ax squared plus bx to the power 1 plus c x to the power 0, right? So a is the coefficient of x squared, b is the coefficient of x or x to the power 1, and c is the coefficient of x to the power 0. So a, b, c are the coefficients, and the roots are alpha and beta. And what is the relationship between the zeros and the coefficients? Yeah, alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a. This is a relationship. Then how do you construct or how do you frame a quadratic polynomial? That's the next thing. Very good. Yeah. So the next thing is, how do we frame a quadratic polynomial? So when you're given alpha and beta, how do you frame the quadratic polynomial? X squared minus sum of the zeros into x plus the product of the zeros. Correct. X squared minus alpha plus beta of x plus alpha beta. Now this into k. This into k. All right. Now to frame the quadratic polynomial, the question can be of 2 types. Either they'll give you alpha and beta and they'll ask you to construct the polynomial, or they'll give you alpha plus beta and alpha beta and ask you to construct the polynomial. Okay. Given alpha and beta, construct the quadratic polynomial, or given alpha plus beta and alpha beta, construct the quadratic polynomial. Both you have to do it here itself. How? If supposing this is 4 and this is 5. So x squared minus 4 plus 5 of x plus 4 into 5. Correct? But supposing this itself is given as 4 and this one is 5. Supposing, then it is k into x squared minus 4x. Because alpha plus beta is 4. Alpha plus beta itself is 4. So alpha plus beta is 4x plus what is alpha beta? 5 plus 5. If alpha is 4 and beta is 5, then it will be 4 plus 5 of x plus 4 into 5. If alpha plus beta, this itself is 4. This one is 4, so 4x plus alpha beta is 5, so 5. So take care, read the question carefully. See if alpha and beta are given or alpha plus beta and alpha beta are given. Yeah. Okay. So I have such questions for you later. We'll just finish this, and the next few questions will be about constructing quadratic polynomials. Now you can continue. Don't have to take the last page. Yeah. Now here we have a quadratic polynomial in variable t, and you have to find the values of these expressions. So how do you always start answering this question? You should keep certain things ready. What? You must keep alpha plus beta ready. Before that, you can compare this. with the standard form. What's the standard form? A t square plus bt plus c. Just replace x, ax square plus bx plus c. Replace x with t, x with t. A t square plus bt plus c. Okay, so on comparing, what's the value of A? 1. What's the value of B? -4. And what's the value of C? 3. Okay, now what is alpha plus beta? Minus B by A. That is -4 by 1, which is 4. And what's alpha beta? C by A, which is 3 by 1 or 3. Finished? Please come on. Okay. Completed in second. Right? All right. So you'll have to keep this ready. To evaluate these expressions, you'll have to keep these two values ready. Alpha plus beta and alpha beta. Okay. Start working. If you're finished, you just have to wait. Yeah, please start working. Yeah. You've completed all the 8, is it? Okay. Yeah, please. Yeah, don't get distracted. Start working. Finished, is it, Anugraha? Oh, that's nice. You also finished? How many of you have not completed? It's good, actually. See, very nice. Not completed, Killer. Completed, girl. Okay. No, I think then. Okay, 1 minute, because others can't wait. So what will you do here? What will you do here? What's common? Alpha? Alpha cube, beta cube is common. So what will you get in the bracket? Alpha plus beta. So what is this? Alpha beta whole cubed into alpha plus beta. We have these two values, no? We have the value of alpha beta and alpha plus beta. So substitute and calculate. All right. Now, because some of them have finished. So we'll just discuss and go to the next one. Then how do you find alpha minus beta? Should use the identity. Alpha plus beta the whole square minus alpha minus beta the whole square is equal to 4 alpha beta. You must use this identity. Okay. To find the value of alpha minus beta, use this identity. You should write this identity by yourself. Okay. Alpha plus beta the whole square minus alpha minus beta the whole square is equal to 4 alpha beta. We know the value of alpha plus beta. What is it? 4. And alpha beta is 3. This is 4. This is 3. So substitute. Minus correct? Alpha plus beta is 4. So 4 square minus alpha minus beta the whole square is equal to 4 alpha beta. So 4 into 3. So now you should work this and find the value of alpha minus beta. All right. To find alpha minus beta, you should use this identity. How many, what are the different expressions you have here? Alpha plus beta the whole square minus alpha minus beta the whole square is equal to 4 alpha beta. So we have alpha plus beta, that's one expression, alpha minus beta, and then alpha beta, correct? Now of these 3 expressions, we know the value of 2 of them. We know the value of alpha plus beta and alpha plus beta. Sorry, we know the value of alpha plus beta and alpha beta. So you can easily find the value of alpha minus beta, right? Then how do you find alpha square plus beta square? Tanya, you can stop. Your father's come. Which one are you working? It's okay. You want to complete? He'll wait. Okay. Yeah. How do you find alpha square plus beta square? Identity. Very good. Alpha plus beta, the whole square, minus 2 alpha beta. Minus 2 alpha beta. This is the identity. Okay. Alpha square plus beta square is equal to alpha plus beta, the whole square, minus 2 alpha beta. So you know the value of alpha plus beta and alpha beta. Substitute and calculate. How do you find alpha square minus beta square? It's like a square minus b square. So a plus b into a minus b. Alpha plus beta into alpha minus beta, right? A plus b into a minus b. Alpha plus beta, we have it here. 4. Alpha minus beta, we found. What did we get for alpha minus beta? We got plus or minus 2. And I said, go ahead with the positive value. Take only the positive value. So you can see here, alpha plus beta is 4 and alpha minus beta is 2. So 4 2s are 8. Then how do you find alpha cube plus beta cube? What's the identity? Alpha plus beta the whole cube minus 3 alpha beta into alpha plus beta. Very good. Alpha cube plus beta cube is equal to alpha plus beta the whole cube minus 3 alpha beta into alpha plus beta. So see here, you know the value of alpha plus beta, alpha plus beta. Substitute and you can find the value of alpha cube plus beta cube. Correct? Next. How do you find alpha cube minus beta cube? Identity. Identity. What is it? Alpha minus beta the whole cube minus 3 alpha beta into alpha minus beta. Correct? And we know the value of alpha minus beta, right? We found. If this is the only question, you have to find the value of alpha minus beta. If supposing they give you only this, given this polynomial, if you have to evaluate only this one, if alpha and beta are the zeros of f of t, find the value of alpha cube minus beta cube. If this is the question. So how do you find alpha cube minus beta cube? Alpha minus beta the whole cube minus 3 alpha beta into alpha minus beta. This is the identity, right? But we know the value of alpha beta. We know the value of alpha beta, but alpha minus beta we don't know. So you have to find. How will you find? You should find it like this. You must find it like we worked here using this identity. You understand? If we have to find alpha cube minus beta cube, this is the identity. But we have only two values, alpha plus beta and alpha beta. But here we have to substitute alpha minus beta. We don't have the value of alpha minus beta. Yeah, you can. Leave the paper. See. So you have to find the value of alpha minus beta, right? How this working? Oh, yeah. Sorry. Okay. Sorry. Yeah. Alpha minus beta the whole cube plus 3 alpha beta into alpha minus beta when it's transposed. Correct. So how do you find the value of alpha minus beta? Should work it like this using the identity. Then alpha to the power 4 plus beta to the power 4. What's the identity? Alpha square plus beta square, the whole square, minus 2 alpha square beta square. This is the identity. Alpha to the power 4 plus beta to the power 4 is equal to alpha square plus beta square, the whole square, minus 2 alpha square beta square. This is the identity. So you can write this as what? Alpha beta the whole square. You can write this as alpha beta the whole square, correct? And do you know the value of alpha square plus beta square? No, we don't know. We can't. We don't have the value. So what is alpha square plus beta square? It is alpha plus beta, the whole square, minus 2 alpha beta. Alpha square plus beta square is alpha plus beta, the whole square, minus 2 alpha beta. And the square. Now substitute the values of alpha plus beta and alpha beta. Got that? We'll do it again. What's identity? We'll do this again. What's identity? It's alpha square plus beta square, the whole square, minus 2 alpha square beta square. Now this can be written as minus 2 alpha beta whole square. So we know the value of alpha beta. But what about this one? No, we don't have the meaning. We can't find. If you already find, you can use it. Yeah. Yeah. If you have already found like this, you can use it. See here, we have already found it. No, you've already found it. So you can use it. You can use it. See, we have found alpha square beta square is 10. So you can use it here, 10. If you have not found it, then use identity. What is alpha square plus beta square? Alpha plus beta, the whole square, minus 2 alpha beta. See, I put the whole square first. Did you notice that? I put this whole square first. This one, this whole square. Now alpha square plus beta square is alpha plus beta, the whole square, minus 2 alpha beta. Now you have you know the value of alpha plus beta and alpha beta. Substitute and calculate. Then the last one is alpha to the power 4 minus beta to the power 4. This is like a square minus b square. This is like a square minus b square. Alpha square plus beta square into alpha square minus beta square. A square minus b square. Alpha square plus beta square into alpha square minus beta square. Now, in this question, since we have got different, sub questions, you can take the values. We've already found alpha square plus beta square. We've already found alpha square beta square. We've already found 10. And alpha square minus beta square also we found. Right? Alpha square plus beta square and alpha square minus beta square we found already. So just multiply. Satakshi, have you finished? You can stop. I'll correct it to the extent you have worked. Oh, cleared it. Sorry. So what is this? Alpha square plus beta square into alpha square minus beta square. Correct? In this question, we've already found. We've already computed alpha square plus beta square is 10. Alpha square minus beta square is 8. So 10 into 8. Correct? 10 into 8, 80. Suppose you have not calculated. Suppose you have not calculated. Then you should find. See, then you should work it like we have done here. Yes or no? Okay. So at the end of the class, we have a test based on this. You will work and leave the papers here for correction. So, okay, let's continue. Yeah. Good. Find the quadratic polynomial. Take the question and work it. Find the quadratic polynomial whose zeros are given to you. Yeah, you can take the help of the slide. Yeah, I think your mom's waiting outside. Okay, if the zeros are given, what are given to you? Alpha and beta, correct? Alpha is 7 by root 3 and beta is minus 4 by root 3, correct? Yeah. Okay, so what's the standard form? How do you construct the quadratic polynomial? K into x square minus alpha plus beta of x plus alpha beta. So substitute the values. K into x square minus, what is alpha? 7 by root 3. Plus beta. What is beta? Minus 4 by root 3. So plus minus 4 by root 3. So it will be minus 4 by root 3. Alpha is 7 by root 3 plus beta is minus 4 by root 3. So minus 4 by root 3 because plus into minus is minus into x plus alpha into beta. Alpha into beta. I've substituted. In this format, I've substituted the values. So next, what the common here, the denominator, it's already root 3. It's common root 3. So 7 minus 4, 3. 3 by root 3. When you subtract 7 by root 3 minus 4 by root 3. What do you get? 3 by root 3, correct? 3 by root 3. But the denominator is irrational, so you'll have to rationalize it. So into root 3 by root 3. See here, the value is 7 minus 4, 3 by root 3, correct? Now the denominator is irrational, so you'll have to multiply and divide by root 3 to rationalize the denominator. And this x, then minus 7 fours are 28. Here you'll have to multiply. So 7 fours are 28, root 3 into root 3 is 3. Now here, 3 into root 3. 3 into root 3 is 3 root 3. By root 3 into root 3 is 3. Correct? So 3 and 3 will get cancelled. So the required quadratic polynomial is k into x square minus root 3x minus 28 by 3. Now, you can even multiply this by 3. The denominator is 3, right? The denominator here is 3. So you can even multiply, supposing, you have this question as an MCQ. So you'll have 4 options. So the question will be, which of the following is the quadratic polynomial with zeros? Which of the following is the quadratic polynomial with zeros 7 by root 3 and minus 4 by root 3? So if you have to pick one of it, see that this one you can multiply by any non-zero real number, right? So if you multiply this one by 3, what will you get? When you multiply this by 3, you'll get 3x square minus 3 root 3x minus 28. This can be the option given to you. When you multiply this one by, see, this k is what? Any non-zero real number. If you multiply this one by 3, so then you will get 3x square minus 3 root 3x minus 28. You can even multiply it by 9. If you multiply by 9, you will get 9x square minus 9 root 3x and minus 28 by 3 into 9. So it is 3 ones are 3 threes are. So 24, 4, 2 carried over, 84. Minus 84. This also can be an option. This can be one of the options and this is the correct option. Correct? Okay. Please work this. You're done? All of you? Now again, find the quadratic polynomial whose zeros are given to you. Alpha and beta are given to you. So what you can also do is, this is one way of working. Substituting the values of alpha and beta straight away in the format. This is one way of doing it. But now these numbers look a little more complicated, right? So what you can do, you can find alpha plus beta and alpha beta, like work it and then put it in the standard form. That's why these two questions. So in this question, when the numbers are simple, you can directly substitute them for alpha and beta in the format. For this also, you can find alpha plus beta, alpha beta, and then put it in the format. You can do it that way also for this. So here, since the numbers are relatively large, right? So instead of putting it in the format and doing the simplification there, you can find alpha plus beta. You can find alpha plus beta. You can find alpha beta. So comfortably work it separately and then write the standard form and substitute the values. All right? Yeah. So here you'll have to rationalize the denominator. You can listen if you want to understand. If you think you know it, you can work. So see here. So this alpha is given to you, beta is given to you. All right. You can take this as alpha and this as beta also. You can take this as alpha, this is beta, anything. Okay, so alpha and beta are given to you. So let's find alpha plus beta. So what's alpha plus beta? This number plus this number. So the common denominator is 3 minus root 2 into 3 plus root 2, correct? The common denominator is 3 minus root 2 into 3 plus root 2. So it's like cross multiplying, no? Like cross multiplying, right? So it will be this into this, 3 plus root 2 the whole square. 3 plus root 2 into 3 plus root 2. 3 plus root 2 the whole square. Yes or no? 3, this is the common denominator. This one into this one is a common denominator. Not sure if you all. Yeah. So it's just LCM. 3 minus root 2 into 3 plus root 2. Correct? Now here we have 3 minus root 2. So you'll have to multiply this with 3 plus root 2. We have 3 minus root 2 here. So we don't have 3 plus root 2. So you'll have to multiply the numerator with 3 plus root 2. Yes or no? Then here we have 3 plus root 2. 3 plus root 2. So you'll have to multiply the numerator with 3 minus root 2. 3 minus root 2. So it will be 3 plus root 2 the whole square, 3 minus root 2 the whole square. Common denominator, nothing else. So 3 plus root 2 the whole square plus 3 minus root 2 the whole square. Denominator, you know it. So now I've used the identity. I have not expanded. I've used the identity. What is a plus b the whole square plus a minus b the whole square? It's 2 of a square plus b square. Or you can expand. See now, you can expand. How to expand a plus b the whole square? A square plus b square plus 2ab. And how will you expand a minus b the whole square? A square minus 2ab plus b square. You can expand. I have used identity. Always try to use, things which are new, so that when you keep using them, that becomes easy to remember also. So I've used the identity a plus b the whole square plus a minus b the whole square is equal to 2 of a square plus b square. So you can see here 2 of a square, 3 square plus b square plus root 2 square. 2 of a square plus b square. Can you see that? You'll get the answer. You can even expand it, children. You can also expand this. You'll get the same answer. Okay. So this is 3 square, which is 9. Root 2 square, which is 2. So 9 plus 2, 11. 11 into 2, 22. 22 by, this is 9 and this is 2. So 9 minus 2, 7. 22 by 7. So alpha plus beta is 22 by 7. Now let's find alpha beta. So alpha beta, when you multiply, alpha and beta cancels, right? They get cancelled. Yes or no? Because 3 plus root 2 in the numerator, 3 plus root 2 in the denominator. 3 minus root 2 in the denominator, 3 minus root 2 in the numerator. Let's cancel. So the product is 1. Now write the standard form. Required quadratic polynomial, write the standard form and substitute. What have you got for alpha plus beta? 22 by 7. 22 by 7. And what have you got for alpha beta? 1. 1. All right. Do it. What? Please work. Finished? Okay. So here you can multiply this polynomial with what minimum number you can multiply with? 7. 7. So then it will be 7x squared minus 22x plus 7. Done all of you? Okay, next one. Find the quadratic polynomial. The sum and product of whose zeros are root 2 plus 1 and 1 by root 2 minus 1 respectively. So what is given here? You're given the sum and product. Alpha plus beta is root 2 plus 1. Alpha plus beta is root 2 plus 1. And alpha beta is 1 by root 2 minus 1. Now here also, if you want, you can simplify and then substitute in the standard form. So what to simplify? Whenever the denominator is irrational, we rationalize it. See, this is the numerator. Root 2 plus 1 is a numerator. That's fine. The denominator is rational, no? Yeah. If the denominator is irrational, then you can rationalize it and then substitute in the standard form. Or if you substitute straight away, you should rationalize it there. If you substitute it straight away, then do the rationalizing. After substituting, rationalize. So what I'm saying is, before you substitute in the standard form, you can simplify, do all the simplification and then just put it in the standard form. So alpha plus beta is equal to root 2 plus 1. Nothing to simplify here because this is the numerator and the denominator is rational. So nothing to simplify here. Alpha beta is 1 by root 2 minus 1. Here we can simplify. So we should multiply by alpha plus beta is root 2 plus 1. Where is it minus 1? I can't see the minus. Yeah, that's on the, no, it's not minus. That's on the board. That's a black, the marker ink on the board. Sorry. Sorry. Yeah. Okay, it's 1 by root 2 minus 1. So you'll have to multiply and divide with, correct? So it will be root 2 plus 1 divided by root 2 the whole square minus 1 the whole square. So it is root 2 plus 1 by 2 minus 1, 1, which is root 2 plus 1. So you can substitute this. Yeah. Yeah, take the help of the working and finish it. I've done it both the ways, I think, for you. Yeah. So whichever way you work, you can check your answer. I'll just tell you what you see here. What you see here is I've simplified and then substituted. Here I've substituted and then I've simplified. You can do it anyways. These are two. This is the solution, alternate solution. Okay. You can work it in any one method. Maybe you can do it like this. If you have tried it already like this, you can check your steps. Finished? Okay. You should not open the bracket because you should leave it in the standard form. The quadratic polynomial, you should show only 3 terms, x square term, x term, and constant. Don't open the brackets. Don't multiply this and x, this and x. Don't multiply. It should be in the standard form. There should be only 3 terms, one x square term, x term, and constant. So this is the x square term, x term, and constant. Here S is sum. S is sum and P is product. You can write this also. You can write the same thing. There's another way of presenting the answer. If you don't want to write this, you can write this itself. Required polynomial is x square. This one. You can write the same thing. You can write this itself here. If you don't want to write this. Finished, all of you? Yeah. Sum and product given. So do you think there's anything to simplify in the sum? Alpha plus beta is given. 1 by root 3 plus 1. Is there anything to simplify here? Should we simplify this? Yeah, because the denominator is irrational. So you should rationalize it. So into root 3 minus 1 by root 3 minus 1. So what will you get? Root 3 minus 1 by 3 minus 1, 2. Then what is the alpha beta? 1 by root 3 minus 1. Okay, so into root 3 plus 1 by root 3 plus 1. So it is root 3 plus 1 by 2. So you can simplify like this. And then you can substitute in the standard form. When the denominator is irrational, you can rationalize it like this. And then now what's the standard form? K into x square minus alpha plus beta of x plus alpha beta. Now you substitute k into x square minus, what is alpha plus beta? Root 3 minus 1 by 2 of x plus alpha beta, root 3 plus 1 by 2. Yeah, good. Here I've substituted first. I told you can do it anyways. Let me work it here for you again. You can work along with me. Done, all of you? Yeah. Right. See this question. If alpha and beta are the zeros of f of y, because y is the variable. If alpha and beta are the zeros of f of y equals 5y square minus 7y plus 1, find 1 by alpha plus 1 by beta minus 2 alpha beta. All right. So we are given a quadratic polynomial, right? F of y, 5y square minus 7y plus 1. Okay, so what are the values of A, B, and C? A is 5, B is minus 7, and C is 1. Then what's alpha plus beta? Minus B by A. So minus 7 by 5 minus B by A. And then what's alpha beta? C by A, which is 1 by 5. So you should always keep this information ready. From the quadratic polynomial, write out the values of A, B, and C, and also alpha plus beta and alpha beta. Keep this ready. Now take up the expression whose value you have to find. You'll have to find the value of this expression. Now take up that expression and take up the common denominator, simplify it as you would otherwise do in algebra. Okay, so see 1 by alpha plus 1 by beta minus 2 alpha beta. Now, see, you can take the common denominator for all the three also. I'm not taking for this because alpha beta, we know the value, no? You know the value of alpha beta, so I'm not disturbing that. You can also take the LCM for all the three. You can take the common denominator for all the three also. I have not taken for 2 alpha beta because alpha beta, we know the value 1 by 5. So I've just left it. I've taken the common denominator only for 1 by alpha plus 1 by beta. All right. So alpha. So what's the common denominator? 1 by alpha plus 1 by beta minus 2 alpha beta will be alpha beta is a common denominator. So you'll get beta plus alpha, right? You'll get beta plus alpha. So beta plus alpha, which is alpha plus beta, minus 2 alpha beta. Correct. Now substitute the values. What is alpha plus beta? 7 by 5. What is alpha plus beta? 7 by 5. Now use this division symbol divided by, what is alpha beta? 1 by 5. Alpha plus beta 7 by 5. Use this division symbol by 1 by 5. Alpha beta minus 2 into alpha beta. What's alpha beta? 1 by 5. That's all. Our intention is to convert the expression given in terms of alpha plus beta and alpha beta because we know only these two values. Something is given, some expression is given whose value we have to find. Now take the common denominator, do something, and the expression should be converted to alpha plus beta and alpha beta so that you can use the values. So that's how you do it. All right, take it on. Done, children? Niveda, Anirudhan? Completed this one?
Yes, ma'am.
Okay.
No, ma'am.
All right. All right. Okay, we'll have to go to the next one. Take a picture, Anirudh. Finished?
Okay, ma'am. Finished, ma'am.
Okay. Yep. Yeah, you can help yourself. It's just common denominator. You can go through the slide and then work it. Okay, so we always start with writing out the values of A, B, and C, and also alpha plus beta and alpha beta. Okay, so keep them ready. Now take up the expression whose value we have to find. Okay, so take that up. Observe the expression first. Now this is 3 alpha beta. You know the value of alpha beta. So why do you want to disturb that by taking the common denominator? Leave that alone. 3 alpha beta, even if you take the common denominator, you will get it. Not that you'll go wrong or something. Don't disturb it. Okay, because you know the value of alpha beta. So you can see it here, 3 alpha beta. Now, I've taken the common denominator for these two and these two. That is all these 4, like alpha beta, alpha beta. So see here. So first for these two, alpha beta is a common denominator. For these two, alpha beta is a common denominator. So alpha square plus beta square. Alpha square plus beta square. Then here, alpha beta is a common denominator. So beta plus alpha. Beta plus alpha. Correct? Yes or no? Alpha beta. So it will be beta. 1 into beta is beta. 1 into alpha is alpha. By alpha beta, just LCM, children. Okay, so LCM here, LCM here. The 2 you can see it outside, plus 3 alpha beta as it is. Next, next, the whole thing, alpha beta, alpha beta. So alpha beta is a common denominator. 1 minute, I'm not seeing the line properly. It's too small for me. I finished this one, right? I said take the LCM for this and take the LCM for this, and that is this step. Now in the next step, what is the alpha square plus beta square? What is alpha square plus beta square? Alpha plus beta the whole square minus 2 alpha beta. So you can see here alpha plus beta the whole square minus 2 alpha beta by this alpha beta, And 2, and I've just written this as, I'm just substituting in one step. Like I'm not, see here, you can, alpha beta, you know the value is 4 by 3. No, I could have substituted 4 by 3 here. You can do, but I'm substituting in one step. Like I'm just simplifying everything. And I'm going to substitute the values of alpha plus beta and alpha beta in one step. That's why you can see here, I've been writing 3 alpha beta as it is. I could have written, no, alpha beta is what? 4 by 3. You can write. You can put 4 by 3 here. You can put 4 by 3 and cancel 3 and 3. And you'll get 4 in every step. You can do that. I have not substituted. I'm substituting all in this step. Okay, so here the numerator is alpha square plus beta square. So it's alpha plus beta the whole square minus 2 alpha beta by alpha beta plus, you can see this as it is, plus 2 alpha plus beta by alpha beta plus 3 alpha beta. In this step, we have everything in terms of alpha plus beta and alpha beta in this step after taking the common denominator and after writing this one as alpha plus beta the whole square minus 2 alpha beta. You can see in this step, we have only these 2 expressions, alpha plus beta and alpha beta everywhere. We have only alpha plus beta and alpha beta everywhere. Now in this step, I've substituted the values. I put the values in this step. All right. Now 2 square is 4. This is 2 into 4, 8, 8 by 3 divided by 4 by 3 plus 2. And see this one, alpha plus beta. I've written like this, alpha plus beta is here divided by, I put, use this division symbol, okay? So that we don't go wrong. See, divided by, I put the division symbol by alpha beta. Then it will become into 3 by 4. Then in the numerator, you'll have to take the LCM again. And then you see 4 by 3 and 4 by 3 gets cancelled. So 3 plus 4, which is 7. So the whole idea is to convert everything to alpha plus beta and alpha beta. That's all it is. This one, we did not include an LCM. We just wrote it as it is. We took LCM for these 2 and these 2. When we took LCM for these 2, what did we get? We got beta plus alpha. So you're happy. We got no alpha plus beta we have got. See here, alpha plus beta we got, and we have alpha beta. So don't disturb this anymore. This is fine now. This one we didn't disturb at all. Now here for this one, when we took the LCM, we got alpha plus beta by alpha beta. So alpha plus beta, alpha beta. Okay, so this is also fine. Now here when we took the LCM, the first one, Here when we took the LCM, denominator is good, alpha, beta. Denominator is good, but the numerator is alpha square plus beta square, whose value we don't know. So use the identity. Alpha plus beta the whole square minus 2 alpha beta. So like this, when you do, you've converted everything to alpha plus beta and alpha beta. Now substitute the values. All right. Niveda and Anirudhan completed.
Going
Yes,
to
ma'am.
complete now.
Yeah. Yeah. Okay. Okay. So the first two questions were about evaluating expressions. The first two questions were about evaluating expressions. Look at this one. If alpha and beta are the zeros of f of x, find the quadratic polynomial whose zeros are 2 alpha plus 3 beta and 3 alpha plus 2 beta. So how do we understand this question? See, we have, or we are given a quadratic polynomial f of x, x squared minus 2x plus 3. Okay, the zeros of this polynomial are alpha and beta. Alpha and beta are the zeros of this polynomial. Now, you have to find a quadratic polynomial whose zeros are 2 alpha, whose zeros are 2 alpha plus 3 beta and 3 alpha plus 2 beta. We are given this quadratic polynomial. The zeros, look at the board. We are given this quadratic polynomial whose zeros are alpha and beta. Okay, this one we understood. Now, what is the question then? We have to frame a quadratic polynomial, or we have to find a quadratic polynomial whose zeros are 2 alpha plus 3 beta. This is 1 0. Like alpha and beta, you will have to frame a quadratic polynomial whose 1 0 is 2 alpha plus 3 beta and whose other 0 is 3 alpha plus 2 beta. Quadratic polynomial, 2 zeros. No, this is 1 0, this is the other 0. Okay, so how do we do this? As always, don't write. As always, okay, what are the values of A, B, and C? A is equal to 1, B is equal to minus 2, and C is equal to 3. And what's the value of alpha plus beta? Minus B by A, so it will be 2, and alpha beta, C by A, which is 3. So keep this ready always. Now come to the new zeros. So we'll let S be the sum of the zeros of the required polynomial. Let S be the sum of the zeros of the required polynomial. We'll have to find a polynomial, right? So let S be the sum. So then what is S? S is equal to, this is 1 0 and this is the other 0. This is only S, no, sum of the zeros. This is 1 0, this is the other 0, and this is the sum of the zeros of the new polynomial. These are the two zeros of that new polynomial or the required polynomial. This is 1 0 and this is the other 0 of the required polynomial. And how do you construct the polynomial? In the standard form, you'll have to substitute for sum of the zeros and product of the zeros, no? In the standard form, you'll have to substitute for the sum of the zeros and the product of the zeros. So we are finding the sum of the zeros of the required polynomial. How do you construct the polynomial? In the standard form, you'll have to substitute the sum of the zeros and the product of the zeros. So we are finding the required sum and the required product we're going to find. So let S be the sum of the required polynomial. So what is S then? This is 1, 0 plus this is the other 0. So what do you get? 5 alpha plus 5 beta. So you can take out 5 common and you get alpha plus beta. And now we know the value of alpha plus beta. It's 2. So 5 into 2, 10. So we have found the sum of the zeros of that new polynomial or the required polynomial. 10 is the sum of the zeros of the required polynomial. Now let's find the product. So again, let P, I think I would have written all that here. Yeah, it's all there. So let P, I'm not writing it fully now. So what is P? Let P be the product of the zeros of the required polynomial. Let P be the product of the zeros of the required polynomial. So we have to find the product of the zeros. So which is 1, 0, 2 alpha plus 3 beta. This is 1, 0. Which is the other 0? 3 alpha plus 2 beta. This is the other 0. And we'll have to multiply because product of the zeros. So you'll have to multiply. So when you multiply, I'll just do it here. So first term into the second bracket, 3 alpha plus 2 beta. Plus the second term into the second bracket, 3 alpha plus 2 beta. Correct? Now you get 6 alpha squared plus 4 alpha beta plus 9 alpha beta plus 6 beta squared. Okay. Now, what is this? 4 alpha beta, 9 alpha beta, 13 alpha beta, 13 alpha beta, and 6 alpha squared plus 6 beta squared. Okay, so this you can proceed in 2 ways. Okay, I'll teach the way I work there. Okay, so what you can do, you can write this 13 alpha beta as 12 alpha beta plus alpha beta. You can write so what do you have? 6 alpha squared. You have 6 alpha squared plus 13 alpha beta plus 6 beta squared. This is what we have. All right. Now what you can do is you can write this 13 alpha beta as 12 alpha beta plus 6 beta squared. Okay. 13 alpha beta can be written as 12 alpha beta plus alpha beta. Now what we'll do? 6 alpha square plus 12 alpha beta plus 6 beta square and plus alpha beta. Alpha beta, we know the value. So we just keep it separately. Now these three, 6 alpha square plus 12 alpha beta plus 6 beta square. And this alpha beta, we put it here. Now you can take out 6 common. You can take out 6 common. So you get alpha square plus 2 alpha beta plus beta square. Plus alpha beta. Don't worry about this alpha beta. We know the value, no? So we are not worried about this. Okay, you know the value of alpha beta. Now here, so 6 into, what is this? Alpha plus beta the whole square, because alpha square plus 2 alpha beta plus beta square is alpha plus beta the whole square. Plus alpha beta. So see, we have worked and we have written everything in terms of alpha plus beta and alpha beta. Now substitute the values. 6 into 2 and 3. Okay, so 2 square and 3. So 2 square is 4, 24, 27. The product is 27. So what's the standard form? X squared minus sum of the zeros into x plus p. Now here you should not write this. You should not write. Okay, so you should not write x squared minus, like this you should not write. Because these are not the zeros of the polynomial which you're constructing now. So you should not write this. When the zeros are alpha and beta, you can write that standard form x squared minus alpha plus beta of x plus alpha beta. You can write if alpha and beta are the zeros of the polynomial you're constructing. Otherwise, you should not write that. Yeah, you cannot write x squared minus alpha plus beta x plus alpha beta because alpha and beta are not the zeros of the polynomial you're constructing now. That is why we've used the letters S and P. So you must write this one. So the required polynomial is, you can write k into also. If your school uses k into, you can write k into. So k into x square minus sx plus b. So k into x square minus, what is this? 10. 10x plus 27. This is the required polynomial. All right. Now, if you say like, now what can like, what's the other way of working? Yeah, what's the other way of working? Now you have split 13 alpha beta as 12 alpha beta and alpha beta, and you work like this. What's the other way of doing? Other way of doing is, after this step, what you can do is just observe. 13 alpha beta is comfortable. 13 alpha beta, because the alpha beta value you know. So keep 13 alpha beta outside. Now take out 6 common here. So you get alpha square plus beta square. Now what is alpha square plus beta square? Alpha plus beta the whole square minus 2 alpha beta. ஆனா இங்க என்ன தப்பு பண்ணுவோம்னா, bracket சரியா போட மாட்டோம். இப்படி போட you're wrong. Wait, I'll just clear the screen and come back to this. See, 6 alpha square plus 6 beta square plus 13 alpha beta. Keep this aside, because alpha beta we know the value. Keep this aside. So here 6 into alpha square plus beta square. Be very careful. 6. See, it is 6 into this whole thing. So you should write 6 into alpha plus beta the whole square minus 2 alpha beta like this. This entire thing is multiplied by 6, because this whole thing is multiplied by 6, right? But if you write like this, 6 into alpha plus beta the whole square minus 2 alpha beta, you're wrong, because this 6 no is multiplied only with this. It's not multiplied with this. So you're wrong. So you might feel I did it correctly, but my teacher did not give me marks or whatever, or you still got the incorrect answer. That's because you've made this mistake. So you should put the bracket and then write inside the bracket. Right? Put the bracket. So if I would always do that, because anybody can go wrong, no? So I would write. I'll write 6. And I know this is alpha plus beta the whole square minus 2 alpha beta. Okay, so I'll put a square bracket and write the identity inside like this: alpha plus beta the whole square minus 2 alpha beta. So you're safe. Then this plus 13 alpha beta. Plus 13 alpha beta. This is fine because we know the value of alpha beta. And now you can substitute, no? We have alpha plus beta, alpha beta, substitute and find the value of S. You can do it both the ways. Yeah, here I've done it like the way I explained first. Yeah, take down, children. for it. Yeah. What is this, Pratish? What have I worked here? What is this I've worked here? No. What is this I've worked here? The answer is in the slide, meaning this presentation here, right? What is this I've worked here? Okay, look at it and tell me. Have you finished working? Okay, you finish it and tell me. You finish it and let me know what I've written there. Okay, so you understood that this is the other way of working which I've worked here, correct? After this step, you can proceed like this or like this, is what I've mentioned here. Have you understood that, all of you? In the step after this step, 6 alpha square plus 6 beta square plus 13 alpha beta. After this step, you can proceed like this. Like you can write 13 alpha beta as 12 alpha beta plus alpha beta like this and proceed like this. Or you can also do it like this. Please make a note of both of it, children. Done, all of you? Done? Completed, Niveda and Aniruddhan?
Ma'am, 1 second, ma'am.
Which you have written.
Finished, Anirudh?
No, ma'am.
All right. Just wait for another minute. Do it fast. Yeah. Next one. This one you can just skip. It's very easy. Yeah, here's the next one. If alpha and beta are the zeros of f of x, find a quadratic polynomial whose zeros are 2 alpha by beta and 2 beta by alpha. And another polynomial whose zeros are 2 alpha plus 3 beta and 3 alpha plus 2 beta. So the answer is simple. It's about understanding the question. So what is the given polynomial f of x, which is 2x squared minus 5x plus 7. This is the polynomial given to us. So from this, what should we do? We should immediately write the values of a, b, and c. A is 2, b is minus 5, and c is 7. And then you should write the values of alpha plus beta minus b by a. And you should write the value of alpha beta, which is c by a. All right. Now, what is the question? Find a quadratic polynomial. That means you should find a new polynomial whose zeros are, this is the second subdivision. Don't see this. This is the first subdivision. Don't see the second one. So you should find a quadratic polynomial whose zeros are these. Like this is 1 0 like alpha, and this is the other 0 like beta. Given this information, you have to construct or frame a new quadratic polynomial whose zeros are this one like alpha and this one like beta. So every time you have to frame a quadratic polynomial, what you need the sum of the zeros and the product of the zeros. That's all. You need to find the sum of the zeros, the product of the zeros. Once you know the sum and product, put it in the standard form. X square minus Sx plus P. We're using Sx plus P because alpha and beta are not the zeros of this polynomial. Some of the two values are the zeros. So we're going to use x square minus Sx plus P. So whenever you have to find a new polynomial, you need to find their sum and product. That is, find the sum of the zeros and the product of the zeros and put it in the standard form. That's all. Okay, can you do that? Yeah. Yeah, we have a question to ask. Yes, Hasif? Yeah, please start working. I just want to say this. When you find the product, what happens? Beta and beta gets cancelled. When you multiply the zeros, 2 alpha by beta into 2 beta by alpha. Alpha and alpha cancels. Beta and beta cancels. So 2 into 2, 4. The product is 4. Yeah. Done, children? See, I've worked all the calculations. I've not missed any step. I've not missed any step. See, everywhere. Converting division to multiplication, everything I've shown. This calculation is of lower standards. We just need to understand how to, approach the answer, right? So how does the question look? We are given a quadratic polynomial whose zeros are alpha and beta. So from that, what should you do? You should write the values of A, B, C and alpha plus beta and alpha beta. Keep that ready. Now read the question ahead. You have to find a new polynomial, new quadratic polynomial, whose two zeros are given to you. So what should you do? You should find the sum of those two zeros and you should find the product of those two zeros. We'll call them S and P. All right, we'll find the sum of those two zeros. So when you find the sum of those two zeros, you'll have to take the common denominator and you should make sure that you write everything using alpha plus beta and alpha beta. That is the idea. Everything should be converted to alpha plus beta and alpha beta. So when you take the LCM, you have alpha square plus beta square. So we write it in terms of alpha plus beta and alpha beta using the identity. And then we substitute the values. So substitute and calculate. Alpha, beta, the product of the zeros, I told you. Beta gets cancelled, alpha gets cancelled. So 2 2s are 4. Correct? Any questions you can ask me. If you have a doubt, please ask me. This is probably the test question, so I'm not doing it now. Because we just did whose zeros are, this one we just did, no? We just understood how to find the sum of the zeros. This is a different quadratic polynomial. No, the given quadratic polynomial is different. The zeros are the zeros of the new polynomial, they are the same, but the given quadratic polynomial is different. So we'll get a different answer. So maybe I'll ask this, so I'll just take a picture and keep it ready. Yeah, look at this one. If alpha and beta are the zeros of the polynomial f of x, x squared minus 5x plus k, such that alpha minus beta is 1, find the value of k. Okay. Every time you're given a quadratic polynomial, every time you're given a quadratic polynomial, this is the first thing you should do. What? A, B, C, and then alpha plus beta. What is alpha plus beta? Minus B by A. So minus B by A. And what is alpha beta? C by A. C by A is K. That is alpha plus beta is 5. And alpha beta is K. Always write this first. When you're given a quadratic polynomial, always write this ABC value, alpha plus beta, alpha beta. Now look at the question. We have an equation given, no? We already know alpha plus beta is 5. But in the question, we have alpha minus beta is 1. So we can solve these two equations, no? We have got alpha plus beta is 5. But in the question, we have alpha minus beta is 1. So you can write these two equations one below the other and solve them. This is one way of doing. I have another way. Okay, so now when you solve, what do you get? This gets cancelled. And then you get 2 alpha is equal to 6. So alpha is equal to 3. Then when you substitute, alpha plus beta is equal to 5. Alpha is 3, no? So 3 plus beta is equal to 5. So beta is equal to 2. So what is k? Find the value of k. The question is find the value of k. So k is equal to alpha into beta. So 3 into 2, 6. I'll just see how I've worked it here. Okay, not use identity. I've done it both the ways. Yeah. So this is one way of working. Understand? We have alpha plus beta in the we have alpha plus beta from the given quadratic polynomial. Alpha minus beta is given to you. Solve. Find the values of alpha and beta. And what is k? Alpha beta. Alpha into beta. So 2 into 3, 6. This is one way of doing. The other way of working it is So the other way of doing it is, this is one way. So this is one way. We should always have these values, right? This one is always there. Finding alpha plus beta and alpha beta is always there. The other way of doing it is, you can connect all this using this identity, right? Alpha plus beta the whole square minus alpha minus beta the whole square is equal to 4 alpha beta. See, in this question, we know alpha plus beta is 5. And we are given alpha minus beta is 1. And k is alpha beta. So we have all these three expressions, no, in this particular situation. So this is the identity that connects all the three expressions. In this identity, alpha plus beta the whole square minus alpha minus beta the whole square is equal to 4 alpha beta. We have alpha plus beta, which is 5. We have alpha minus beta, which is 1. And 4 alpha beta, it's okay. One unknown can be there. And what is this alpha beta? Actually, k. So you can find the value of k. You can do it in these two methods. Yeah. What we just understood this here. So when I've written solution 2 times, that means this is the alternate solution. Okay. You can do it like this. Or you can solve the two equations, find alpha and beta. And we know alpha beta is k. Alpha beta is k. So alpha beta is k. So 3 into 2 is k. K is 6. Okay. Done. Yep. Yeah. Tell me, what is alpha plus beta? What is alpha plus beta? What is alpha beta? What is the condition given in the question? What is alpha square plus beta square? Oh, can we substitute? You solve the C. This equation has this unknown K. So solve this and find the value of K. That's a question. Find the values of K. So you should solve this and find the value of K. All right. Good. Okay, so this is what we always do. When we have a quadratic polynomial, we write the values of A, B, C, then we write out alpha plus beta and alpha beta. So this is standard. Now there is some condition or an equation given in the question. So we work with that. Okay, so we work with that. This is given to us. So now we are converting this using an identity. We are converting this to alpha plus beta and alpha beta. Okay, so that is alpha plus beta the whole square minus 2 alpha beta is equal to 24. Correct? Yeah, now substitute the values and you get this. Take the common denominator. Take the common denominator. So k square. Is it hold? Should I turn it off? Okay, so yes. Okay. See, you can divide by 8 here also. You can divide by 8 throughout here also. The 8 is common. No, you can divide by 8 here itself. I have done it here in this stage. So I've taken the common denominator k square. Always the highest power is the LCM. The least power is the HCF. HCF is least power. LCM is highest power. So k square, highest power. K square is LCM, k square. So you'll get 16 minus k into k, no, is k square. So into k here. K into k is k square. So 8 into k, 8k. Common denominator, that's all. Okay, then cross multiply. Then we see that 8 is common throughout. So I'm dividing every term by 8. I'm dividing every term by 8. You can do that. You should divide everything by 8. Okay, so I'm dividing every term by 8. So when you do that, you're just simplifying the equation. Now, if you forget to do it also, it's okay. But when you divide, you're simplifying the equation. So now see, this one looks now like 2 minus k is equal to 3 square. It looks simpler now, that's all. Now bring all the terms to one side because see, what are the terms here? K square, k and constant. So it's quadratic. So you'll have to proceed by splitting the middle term. Look at the terms in this equation. See here, k square, k and constant. So it's quadratic. So what should you do? Bring all the terms to one side and split the middle term and find the factors. Yeah. So that's what it is. So I brought all the terms to one side, k square term first, then the k term, and then the constant. So split the middle term. You have k plus 1 into 3k minus 2 is equal to 0. Equate k plus 1. Equate each of it to 0. So k plus 1 is equal to 0. So k is equal to minus 1 or 3k minus 2 is equal to 0. K is equal to 2 by 3. That's why the question is find the values of k. So k can be minus 1 or 2 by 3. The value of k can be minus 1 or 2 by 3. All right? Yeah. Finished, all of you? Online children? Aniruddhan and Niveda?
Yes, ma'am.
Yes.
Okay. Okay. Swati, finished?
Yes, ma'am.
Okay. So see, everywhere you're just given a different condition. That's all. The given condition is different. The given condition is different. Okay, so this is the test question then. The given condition is different. See, it's similar to this one. Very similar. See, alpha and beta are the zeros of this polynomial. This condition is given. Find the value of k. Okay. Similar question you can see here. Find the value of k. You're given a quadratic polynomial. Correct? Whose zeros are alpha and beta. And this condition is given. Find the value of k. Yeah, this is a test question. All of you come. Online children, work it and send the image on WhatsApp for me. One of you come, Srivatsan, come give one paper for all. Take one sheet, take this question and start working. Yeah, just pass, you take and then pass it to the girls and we give everything to the girls. That's it. Write your name, all of you, on the paper. Huh? Just leave the Bhavisha to put the papers, so she'll take it. Just give it to her. Yeah. Pass it behind it. So extra papers, just leave it on the table. I'll take it later. Yeah, take the question. Write your name first. And just 10th standard. Don't write your section, school, and all that. 10th standard, that's all. Your name and your standard, that's it. And date. 6th April. Write the question and work the answer. Write test 1. Because it's the first test, I'm going to correct and give you marks. So test 1, this is. Online children must work this and send the picture to me on WhatsApp. Finished? Yeah. This one also. No, this one looks. One second, similar. So, yeah. Yeah, this question. Good, Swati. I've received the first image. This is the next question. Please try this. It's okay this time, Swati, but you have to write the question. All instructions I gave the children here. I don't see the question. For those who are finding the second one not so easy, you have an option. That's it. You can try it. If you're not able to do it, write all the identities we have seen in this chapter. Supposing the second one you're not able to try now, you need more time. Write all the identities we have learned in this chapter. Complete these identities. Then write those two identities which has alpha plus beta, alpha minus beta, and alpha beta. There are two identities, no? Write all these identities. Either try this question or complete these identities. Yeah, it's time, children. Yeah, children. So what is squared difference? Hand over your papers. Squared difference. Okay, first hand over your papers. Write your name. Make sure you've written your name. Okay. Okay. See, you've written correctly, but you should use that identity. What is alpha minus beta? You should use this alpha plus beta the whole square minus alpha minus beta the whole square is 4 alpha beta. From that, you should write what is alpha minus beta the whole square. Not wrong, otherwise. Second one? Yes. You've done. Kind of looks kind of somewhere you've got it. I'll show you the answer. Yeah, children. Yeah, please stop working. Hand over your papers. No. See, after this, I'll not collect. That's it. See, I'm counting 10. After that, I'll not collect. Here, you can just have a look at the answer, like squared difference, that one. Squared difference means, see, squared difference. Squared difference. Squared. Correct? Squared. Something is squared. Squared difference. So it means alpha minus beta the whole square. So alpha minus beta the whole square is given 144. The squared difference is 144. That means alpha minus beta the whole square is 144. Now using this identity, what is using this identity? Alpha plus beta the whole square minus alpha minus beta the whole square is 4 alpha beta. So from that, what can you get? Alpha plus beta the whole square minus alpha minus beta the whole square is equal to 4 alpha beta, right? So what is alpha minus beta the whole square from this? It is alpha plus beta the whole square minus 4 alpha beta, correct? I'll share the images on WhatsApp. It goes like that. You understood what is square difference, right? All of you understood what square difference? Squared difference means alpha minus beta the whole square. This is given to be 144. So this condition is given. You'll have to work with this condition and find the value of P. All right? Okay. All right, children. So that's it for today's session. Thank you so much, online children. You can leave the call.
Thank you, ma'am.
Yeah, thank you.
Thank you, ma'am.
Thank you, Swati. Thank you, Niveda.